Hi folks, Mr. Long for part 2 of developing definitions of inverse trig. So this should be the answer that you've developed here. Um, I'll just highlight around this right here. So if you work through the cos example, that's just check your answers and make sure specifically if you want to do a quick check, you can check that column right there and know if you're correct. And what we're going to do now is move on and do some examples. So what we're going to do is we're going to simplify those two things. So cos of tan inverse of x. So, and sine of cos inverse of x. And I have to tell you that this is something I struggled with initially when I did this, because a lot of this work can be done without triangles. But for me personally, I need the triangles to understand what to do. So here's what we have to do. Start here. So I know that that ratio is x over 1. So all I do is I write a triangle out, a right angle triangle, or draw out a right angle triangle, and I have angle y, right? Because this right here is worth an angle. Tan inverse of a ratio is an angle. So this is angle y, and I know the tan ratio. I know that the tan ratio is worth x over 1. Opposite is x, and adjacent is 1. Okay, so that's what I know from that definition. And again, with BEDMAS, I start from the inside and work out. I know my ratio of the triangle I'm working with is x over 1, and tan is opposite over adjacent. So, and that's angle y. I always write angle y, right angle triangle. I put y in the same spot every time. Pythagorean theorem allows me to get the hypotenuse. And I'm pretty sure we remember that this is 1 minus x squared. So now that I've done that part, now I need to do the cosine. So what's the cosine of angle y? Well, the cosine of angle y is going to be cos is equal to adjacent divided by hypotenuse. So the answer is just going to be 1 divided by the square root of 1 minus x squared. Okay, and that's the answer to this. Really odd, right? But it's just, again, it's definitions of cos inverse and tan and sine inverse in terms of the angles and the ratios. Okay, so process is the same over here. Let's do this one. So again, I know that cos inverse of x represents an angle, which we call y. That can be x over 1. So again, I draw a right angle triangle. Angle y goes here, right angle, and I know that the ratio of cos, okay, cos inverse, the ratio of cos is x over 1. And cos is adjacent divided by hypotenuse, okay? Oh, wait a second, I apologize. When tan was opposite over, that should have been 1 plus over here and 1 plus over here. That shouldn't have been minus because it's the hypotenuse, so we have to add the squares instead of subtract. Okay, so back to this one. Sorry, back to this one here. So cos inverse x over 1 means that the adjacent is x, the hypotenuse is 1. So now what I do is, again, I use Pythagorean theorem to get this side, which I can call L, and L squared would equal 1 squared minus x squared, or L would equal the square root of 1 minus x squared. We also know that that is the opposite side, okay? That's the opposite side. So now that I know all the sides of the triangle, now I can do the sine. What's the sine of this angle? What's the sine of that angle? The sine of that angle is opposite divided by hypotenuse, which is 1. So that's going to equal square root 1 minus x squared over 1, which just equals the square root of 1 minus x squared. Okay, folks, so that's how you do that. That is really weird. I know it's weird, but you'll need to be able to do this in order to do the derivatives. All right, so that's our video there, and we're going to move on. The next thing we're going to work on is derivatives.